Today we are going to be talking about standard deviation and z-scores. By the end of this video, you should be able to calculate and interpret standard deviation and z-score. First, a standard deviation is a measure of how spread out a set of data is. So here we have three examples. In this first data set, it is all the same number, and that data set has a standard deviation of 0. This means that it's not spread out at all. It's all the same. Our second data set, that is ones and tens, has a standard deviation of 4.5, which that in and of itself doesn't tell us very much, but when you compare that with data set 3, that has all of the numbers from 1 to 10, and if you calculate the standard deviation, you get 2.87, that tells you that data set 2 is more spread out than data set 3, which is more spread out than data set 1. So data set 2 is the most spread out of these three, and data set 1 is the least spread out. Now, a dataset's standard deviation, which is represented by the Greek letter lowercase sigma, can be calculated using our calculator. There is a formula that you can use, but it's rather nasty, so we're just going to use the calculator. First, we are going to click the Stat button, and then go to Edit, which is number 1. Then we're going to type all of the numbers in L1, which stands for List 1. You can type the numbers exactly as they appear on the paper. You do not have to put them in order. After you type the numbers in, you click Stat again. Then you go over to the right to Calc, and you're going to click number 1, which says 1 var stats, and that stands for 1 variable statistics. And you click Enter a few times, and it gives you this screen. The two numbers that we are interested in right now are the first number, which is the mean. So we're going to write that down. And we're going to round to 2 decimal places for right now. So this is the mean. And then we are interested in this number here. It says sigma of x, which stands for the standard deviation. And again, we're going to round to 2 decimal places, so that would be 3.94. Now, ultimately, we are interested in z-scores. A z-score of a particular data point is the measure of how many standard deviations that point is away from the mean. So, if a data point has a z-score that is greater than 0, that means that that data point is above the mean. If its z-score is equal to 0, that means it is 0 standard deviations from the mean, so that is equal to the mean. And if a data point has a z-score less than 0, then that means it is below the mean. So, if a data point is 2.5 standard deviations above the mean, what is its z-score? Since the z-score tells us how many standard deviations a point is from the mean, its z-score would be positive 2.5. And we know that it's a positive number because it says that it is above the mean. What value would this be for the data above? That refers to this set of data where we already calculated the mean and the standard deviation. So if you start at the mean, you want to go 2.5 times the standard deviation above the mean and see what number that is. So if you type that in your calculator, you get 20.07. So the data point 20.07 would have a z-score of 2.5 if it were a part of this data set. Now let's take a look at the z-score formula. And this is on your SOL formula sheet, so you do not need to memorize this. The formula for z-score is x minus mu, which is a Greek letter, divided by sigma. And in this case, mu represents the mean, sigma represents the standard deviation, and x represents our data point. A data point is said to be statistically unusual if its z-score is more than 2 standard deviations from the mean. This means that the z-score would be less than -2 or greater than 2. So let's look at an example. Kelly's test score on the rational equations exam was 95. If the class average was 78 and the standard deviation is 5, determine if Kelly's score is unusual. So we have 3 numbers in this problem. Kelly's test score was a 95. That is going to be our x. The class average was 78. Average is another word for mean, so 78 is going to be mu. And then the standard deviation is 5, so 5 is going to be sigma. We need to calculate her z-score. So if we use the formula above, we have z equals 95 minus 78 divided by 5. If you put this in your calculator, you get 3.4. So, is Kelly's score unusual? Yes, because her z-score is greater than 2. Let's look at another example. You have a normal distribution with a mean of 235.7 and a standard deviation of 41.58. Which data point has a z-score of -3.45? So if we look at the information we are given in this problem, we are told that mu is 235.7 and we are told that sigma is 41.58. We are also told that the z-score is -3.45 and we are trying to find x. So if we use the z-score formula, we have -3.45 equals x minus 235.7 over 41.58. And we need to solve for x. So to solve for x, we first need to multiply both sides by 41.58. And when you do that, you get -143.451 equals x minus 235.7. Then you add 235.7 to both sides, and you get that x is equal to 92.249. So this problem still uses the idea of z-scores, but we're kind of going backwards and trying to find x instead of z. Lastly, z-scores can be helpful for comparing two different sets of data. So, suppose your friend receives an 80% on a test in AP World History and a 90% on a test in underwater basket weaving. The average score on the AP World History test was a 72 with a standard deviation of 6.5. The average score on the underwater basket weaving test is 88 with a standard deviation of 3. Statistically, which score is better? So we have a lot of information in this problem. First, let's label things. We know that your friend got an 80 on an AP World test. So that's going to be our X. The class average for AP World was a 72, so that's going to be our mu. And the standard deviation was 6.5, so that is sigma. Let's calculate the z-score for the AP World History test. So the z-score is going to be 80 minus 72 over 6.5. And if you put that in your calculator, you get that the z-score is 1.23. Then if we look at underwater basket weaving, their test score was a 90, so that is X. The average is 88, so that is mu. And the standard deviation is 3, so that is sigma. So let's calculate the z-score for underwater basket weaving. So the z-score will be 90 minus 88 divided by 3. So this z-score will end up being 0.67. So statistically, which test was higher above the mean? Well, that would be AP World History. So compared to the other students in that class, your friend did better on the AP World exam than they did on the underwater basket weaving test. So even though the actual grade on the underwater basket weaving test was higher than the actual grade on the AP World test, compared to the rest of the class, your friend did better on AP World.